Well, hello, geometers and seekers of general truths. We continue our study of parallel and perpendicular lines with some unusual examples here. So we're given a line, y equals 5, and a point, and we want to create another line that is parallel to this first line and passes through the given point right here. All right, so I always like to start out with, let's just graph. We're supposed to graph both lines, but let's just graph, and we can do a reasonable sketch here. So let's say we're gonna go 5, right? Now y equals 5 is a horizontal line, right? So it's a line that has a slope of 0. It's a horizontal line, and we want a line that's parallel to that. So the line we're looking for must also be a horizontal line, and it has to pass through negative 5, 8. So let's say negative 5 on the x-axis is here. This is 10. So maybe right here is 8. Okay? So it has to pass through this point. Well, the x-coordinate here is really irrelevant. The fact that it passes through negative 5 is really irrelevant because the line we're looking for is horizontal. So it must pass through every single x-coordinate. What matters here is the y-coordinate, because we're looking for a horizontal line. So it has to look like this, and it has to pass through negative 5, 8. And the equation of this horizontal line is y equals 8. So look back at some of the notes on horizontal and vertical lines for a brief refresher if this idea doesn't make sense to you immediately. But the main reason here is that y equals a number is the equation of a horizontal line, right? And we know that a horizontal line is going to pass through every single x-coordinate. What really is the question here is how high or low is it here on the xy plane? And in this case, it has to be high, just high enough so that it passes through the y-coordinate of 8. Right? So the y-coordinate of this for every point on this line is always going to be 8. So now let's look at another example over here where we are asked to, and let me do one more thing. Let me label these axes as the x-axis and the y-axis so that it's clear that those are axes and they're not some other line. We start out with a line that's x equals negative 2, and remember, when we have an equation of a line that just uses x and a number, that means we are looking at a vertical line. So x equals negative 2 looks something like this. And we want a line that's parallel to this red line and goes through the point 3, negative 8. So 3, negative 8 is, somewhere down here. Right? 3, negative 8 is somewhere down here. And we want a line that goes through this point and is parallel to this red line. So because the red line is vertical, we also know that our line must be vertical because we're looking for a parallel line. So it must look something like this, right? There's just 3, negative 8. And the equation of this particular vertical line is x equals 3. Because again, for a vertical line, the y-coordinate doesn't really matter. It's this coordinate here that matters. Every single point on this particular line has an x-coordinate of 3. That's why we use the x here to represent that. Right? So hopefully this gives you a sense of working with parallel lines of other lines that are vertical or horizontal. It's kind of a special case.